This tutorial will cover the motion simulation feature in NX 9. So what I'm going to do is get a couple parts that need to be simulated drawn real quick so you can skip ahead if you're comfortable with drawing parts. So I'm going to go ahead and create new model, just keep it in inches, moving it away from this folder. Remember, that's a bad idea to put it in that folder. I'm going to put it in my desktop, NX. I'm going to give a new directory here. I'm just going to call it motion. Okay, and part, I'm going to name this, let's call it pin, and it's a model. Basically what I'm going to do is make a pin, and that's going to serve as the pivot for a link to rotate around. So a pin's going to be pretty simple. It's probably just going to be a cylinder. I think it's the simplest thing to do. So I want to go to home, create a sketch. Doesn't really matter what plane you pick. I'm going to go ahead and put a circle at the center, and let's call it 0.5 in diameter. That looks good. Finish the sketch, extrude. Let's just do an inch. And inferreds, okay, it'll give me a solid part. Alright, so that's the pin. I'm going to go ahead and save that. That's all I'm going to do for that. Obviously, when you're making this for real, I mean, you'll use whatever parts you've drawn. I'm just doing some sample parts real quick for this. So I'm going to leave this open and create a new part that's going to be the actual link itself. So inches, model, same folder. I'm going to call this link though. Link. Okay. And now, again, go back to home, start a sketch, XY, okay. I'm going to make the center hole, which since it's 0.5 on the pin, I want to do 0.5 here, and then I want to come somewhere up here and do 0.5, and then what I want to do is change to 1 inch just by typing in 1 inch, and I want to put the outside of the link there and there. I want to check all my dimensions here to make sure these are right. And by the way, I don't really say what I'm doing, but I'm hitting escape real quick to cancel out from drawing a circle so I can actually select these things. So if you can't figure out how to select the dimensions, just hit escape a few times and it'll cancel out whatever you're doing and let you select things. So what I want to do next, I haven't set a dimension for the center to center, it's just whatever I drew it at. So I'm going to double click that. And this is something, I believe it's new for NX 9. So when I double click that dimension, I get this measurement dialog here, and this is a reference. It's basically a measurement. It doesn't actually drive the geometry. So if I click this over to keep expression and change that to 5, or sorry, keep expression, adjust geometry and close, then it converts it to an editable dimension. It's kind of weird. It's I've had to kind of learn that one on my own, but once you know what you're doing, it makes sense. That's just like this 0 here. I can't edit that 0. I can go through the same process of double clicking it and set that to something I can adjust, and it'll work. So what I need to do now is connect the tangents. So tangents can be kind of a pain in NX. So it kind of jumps between the center point and a tangent. So I think it says arc. So I think, yeah, I was close enough that it let me pick. So I want to do point on curve, and note that it automatically puts a tangent constraint up here. So I want to go ahead and get it down to there, and that did what it was supposed to do. I'm going to click up there, and it did what, oh, I broke it. What did it do? So sometimes that's something that I've seen happen now in NX 9. I'm not exactly sure what that is. I'm going to go ahead and try deleting that. No, it's not going to let me do it. Let me retry drawing that line and go top, bottom to top. I know that shouldn't fix it. It's not supposed to work like that. Well, that wasn't what I was supposed to do. So again, this is one thing I don't like about NX is sometimes it's a little picky. So it worked that time. So that just started noticing that behavior in 9. I'm not exactly sure what it is. I'm sure there's a logical explanation for it, but it's kind of annoying. It's not readily apparent what it's doing. But anyway, generally if you just delete something and then redraw it, that somehow fixes it. Alright, so what I want to do now is go ahead and trim away this part, so I'm going to use the trim tool. So I'm going to go through the direct sketch dialog here and do quick trim, and I'm going to quick trim away that, and I'm going to quick trim away that. And now I've got the basic link geometry. This is something I could extrude. So I'm going to go ahead and finish the sketch. I'm going to extrude this. I'm going to select all the curves, and then I need to make sure I select the bores, and then I'm going to set it to 0.5. The pin was 1 inch, so yeah, I want to do 1.5 for that. And then I've got the link. So those are the two parts that I'm going to try to do a motion simulation for. So the first thing I need to do is actually create an assembly that's got these things together. So that's the next thing. So File, New. Instead of Model, I want to do Assembly. Keep it in inches. It's in the same folder. I'll just call it Assembly. I'll get rid of the 1. And then OK. Okay, so since I have these parts open, I can just double click both of those, and now I guess I'll try double clicking. I don't know if I've ever done that before. I generally do them one at a time. We'll see what happens. So I want to position by constraints. I'm going to hit OK there. Okay, that just popped them in there. And so that's interesting. It's a little different behavior when you add multiple parts. So it just dropped them in at the origin, and now it puts up the constraints dialog here. So if you want to follow the process I used in the last tutorial, you just add them one at a time. Add the first one, fix it, and then add the next one and use by constraints. Going this way, I definitely need to fix this thing first. Since I use the same coordinates, the XY plane, for drawing both parts in the same origin, they automatically line up. If they don't line up, you're going to have to either move them around to get the constraints to work, or just apply constraints and see what happens. But since they're where I need them to be, I don't need to try to move them. I'm going to go ahead and fix the pin. And I need to get that back. So assembly constraints, and then I need to do my concentric constraint, which so I'm just going to click here. There's two edges there. Note at the bottom down here it says edge and pin. So I'm going to click that, and then note that it basically eliminates edge and pin from the selection list. So now it says edge and link. So that's kind of nice. I don't have to try to figure out which one I'm picking, so it automatically knows once I pick one, it eliminates that from the selection list. Hit OK, I've got my constraints. Okay, now I should be able to move component, pick the link, put the handles up, and drag this out of the way, and I should be able to rotate around. So again, that's what we covered last time. That's just basically a, and it shouldn't, let me try this. Yeah, it's not going to let me move it. Just okay, so I'm going to cancel that, but that's basically the constraints I want. So that's as far as an assembly, I can move it around in the constraints, but it's really not. It's not a physical simulation. It doesn't do the real kinematics or kinetics. It just follows the constraints. So if I want to do an actual physical simulation for this, I actually need to go into a different module here. So I'm going to go ahead and save this, and then I'm going to go up to File, and then I'm going to go to Motion Simulation. Okay, so first thing I need to do is create a simulation. So I'm going to come up here into the Motion Navigator, which if you're on the wrong tab, it's this top one that's got all the links in it. I'm going to click my assembly, right click, New Simulation. So you can just do pure kinematics if you want to. I'm just going to do dynamics. It does the kinematics and kinetics. There's some other options here: flexible body, co-simulation, motor driver. I haven't really experimented much with those. I mean, obviously flexible body would be kind of interesting to do if you're dealing with things that have lots of compliance. I haven't had much experience with that. I might try it in a later tutorial. But for now, I'm just going to keep it pretty simple. Note that I can name my simulation. Motion one's fine with me, so I'm just going to click OK. Alright, so see, this is why it's kind of nice to go ahead and do especially concentric constraints in the assembly, is because whenever you do the motion simulation, it tries to automatically map the joints from the assembly into actual kinematic joints. In this case, it mapped the pin to link, that concentric one, to a revolute joint, which is what I want. So revolute joint's in there. I don't think it grounded the pin, so let me look at my, so over here in joints, I'm going to open that up. It did. It just didn't say it did. Yeah, there it is. So it didn't say it mapped that over, but since I fixed the pin, it automatically added this this ground joint here, which basically welds this pin to the ground, and that should be a sufficient set of joints for this. So I can of course delete these things if they're not right, delete these, and then add new joints. To add new joints, what I need to do is go back to home, and then I've got my buttons here for adding links. So if again, whenever I bring something in from an assembly, the solid models there are all individually going to be mapped to a link, but if I need to create a link from something that hasn't been mapped over, or if I draw a new part and then bring it into motion simulation and I need to create a link for it, I need to go through this process. But since they're both done, I don't need to do it. The joint dialog, you can under type see all the different kinds of kinematic joints. This has basically all the standard joints you'd learn about when you take statics or statics and dynamics. So I'm not going to go through what these things are. You basically need to take a class on this stuff to know what these all are. So I'm assuming that at this point you've already taken a dynamics course. You know a little bit about dynamics. Otherwise you're going to have to research exactly what these joints are. So revolute is the most basic kind of joint, though. It's a hinge joint. So if you don't know that much about what these kinds of joints are, revolute's pretty easy to explain. It's basically just a hinge. So it can rotate. So in this case, this link can rotate about this pin, but it can't slide up and down. If you want it to rotate and slide, that would actually be a different kind of joint called a cylindrical joint. If you want it to just translate along an axis, there's a slider. So since those are all set up, I don't really need to do anything, so I can go ahead and close out of that. So what's going to happen if I try to simulate this now? I think gravity's on by default in this. I know you can change it, but if gravity's on and it's in a direction where there'll be a force that causes this to rotate, where the force creates a moment, whenever you simulate this, it'll just be the link trying to fall under gravity. So I'll go ahead and try solving it just to see if anything happens. So I'm going to click solve. There's no solution. I forgot to make one. So to make a solution, let's see, I need to go over to motion, right click, and then new solution. So normal run, that's fine. I guess there's other options here I haven't really done that much with. Kinematics, dynamics, or static equilibrium. So we're wanting it to move. So kinematics, dynamics. This is the time. So a second, 50 time steps. Here you go. Here's where you can enter gravity. So gravity is in this system. So I can pick a vector for gravity. So let's pick a vector that'll actually lead to motion in this. So let's do that. So that'll basically be pulling it down, and then there's a gravitational constant. And note you can change the units to whatever you need. And then okay, now I should be able to click solve and hopefully get a simulation. So it happened really quick. This is a really simple mechanism. It doesn't take any time at all to solve it. So I should be able to click animation up here. I get the animation control. I should be able to play, and there we go. We have a simple pendulum. So it looks like it's supposed to look. So that's already pretty handy. I mean, I could simulate pendulums, double pendulums, lots of things with this. If I want to get some data out of this, I can go to XY graphing, and I could do new. So over here in Motion Navigator, right click on that, new. And so now I get the things I can graph. So I can do my links, I can do the joints. So say I want to know the angular velocity of the joint, I can do, let's see, I want to do the revolute joint, which is that one. And so if you note when I'm clicking over here, they change over here. If you don't name these descriptive things, then you basically have to use this dialog to figure out what you're clicking on. So that's what I want. I want velocity, angular magnitude. That's my that would be, I guess, it would be the y-axis. So I need to add this down here. So that, select angular magnitude, and this is where it took me forever to figure this out the first time. This is what you want on the y-axis, so you need to click plus, and it'll add it on the y-axis. Click X, and it'll be time. You can do something user-defined if you want to plot something versus something else. A lot of times you want it by time. Some of the times, if you're doing things like motion ratios, you want to plot it according to some other motion. So, but I want to do time, so I have to add this to Y list, and of course you can add more to this graph if you want to. You can put a title for it. I'm going to click OK. So now it defaults to using the viewport you're at, or you could break it out into a window. I'm going to break it out into a window. And there you go. You get a nice plot. So that's a simple motion simulation. I'm going to show how to actually drive this under some kind of an external force. So what I want to do is add a driver. So up here in the setup, I'm going to click driver. I want to drive a joint. So I'm going to pick over here in the motion navigator, I'm going to pick that revolute joint. And then I can add the different kinds of motion. So none obviously doesn't do anything. Constant, I can drive it with a displacement. I can drive it now. Note the arrow direction that defines the displacement in that direction, positive, negative, the sense of it. And then there's initial velocity and acceleration. So I could drive it with an acceleration. It'll drive, so it'll just keep spinning up basically forever. So that's okay. We'll try that. So I'll leave it all like that. Click OK, and now I've got that driver. So if you go under driver container, you'll see that driver on the system. So by adding drivers, you can put all sorts of external forces on your simulation. So now I'm going to go ahead and solve, and note it just solves just almost instantly. Bring up the animation, play, and you can see that. So note though that when I did that, it didn't. When I just had gravity on it, it moved a lot faster. Since I added this driver to this joint, that adds a kinematic constraint. And so gravity's still in there. It'll show up as the reaction force down here in the pivot. Let's see if I can actually get a chart of that. So what I want to do is go into XY graphing, right click, new, and then I want to do reaction forces if I can. So let's look at, they'd show up in joint 2. They should. So force magnitude. Let's add that and just see what we get. Yeah, so you can see the force. This is the magnitude of the force acting on it. This is in pounds. Of course, since I didn't set mass properties and any of this stuff, I mean, it's not really, the results don't really mean that much. I actually have to set the mass and the density of the individual links to get something that makes sense. But it is, in this case, since I'm operating in the inch-pound system, I get forces in pounds of force. But this shows the reaction force. I can break that down into components using the coordinate system. I can add things like springs and dampers to the system, bushings. So if you need a compliance, so this is really good if you're doing something like a vehicle suspension, and I mean, you've got bushings that they're not perfectly solid. So even if you're treating your links as if they're solid, you could have joints that were bushings that made it nice. So basically, for those of you that are familiar with atoms, you can do pretty much everything you could do in atoms in this. And I think actually, I'm not sure what the solver is behind this. I know some CAD programs actually use atoms, and it might be atoms for this. I'm not exactly sure what the solver is. So very, very powerful. You can do all sorts of things to it. So I think one other thing I do need to do is show how to actually set the material properties for these things, so you get correct masses for these things. Is kind of important. I can't remember how to do that off the top of my head, so I'm going to experiment a little bit here and try to figure that one out. So I'm going to go into these links. I'm going to right click that, and I'm going to edit it and see if that can help me out. Mass and inertia. Okay, so mass properties option, I could do user defined, so I can enter the mass in the inertia tensor here. One of the actual nice things about using CAD is you don't have to do this process. So I believe you can set the density somewhere of the material, and it'll get it, calculate it for you. If you're using something where you basically just have kind of generalized geometry for a part, I mean, you basically just drew a rough approximation of the part, and it doesn't have the same mass properties, this is where you would enter the mass and inertia properties. So again, you really need to take a class on dynamics. I mean, mass, everybody knows what mass is. This stuff, if you haven't had a dynamics class, you need to take a dynamics class. So I'm going to go ahead and set that back to automatic and do a little bit more searching. So those of you that are taking the class and just need to do the homework, you can check out right now and do the assignment. I'll stick around and try to get this thing figured out here for changing the density of this part. You might have to go to, I can't remember how to do this. I always forget how to do this. Actually, I'm going to pause it. I'm going to figure it out, and then I'm going to come back and tell you. So pause. Okay, I'm back. I figured it out. It's one of those things that's kind of moved around in NX9. So basically, to change material properties, you need to go over here to Menu, and then Tools, and then Materials, and then Assign Materials. So I click that. I pick the body that I want to assign a material to. So let's do the link. I'm going to say that's made out of, let's call it 6061. Then Apply. And then I want to pick the pin. Let's call that Steel 4340. That's super overkill, but okay. That's new. Let me pick that body. Let me pick a different material. 6061. Okay, I don't know why that's not working. Let me close this. Let me try it again. Tools. Material. Assign material. Click that. 4340. I have no idea why that's not working. Let me try this a different way. Menu, Tools, Materials, Assign Material. I'm going to go over here and pick Pin. That didn't work. Pin, okay. That just worked 5 minutes ago. I have no idea why it's not working. Alright, I'm going to pause it again and then figure that one out. Okay, I'm back. I'm guessing what's going on is that since I'm assigning these in motion simulation, since this is fixed, it just doesn't accelerate, so it doesn't really, the mass properties don't mean anything since it's fixed. And I'm assuming since it just treats it as a ground, it won't let you set the material properties for it. I've tried a couple different things, and that's what I'm guessing is going on. The part that actually does move around, though, you can definitely set the materials for, so that's working just fine. It's just the ground part, so I'm guessing that's what it is. So I'll think that's it. For the assignment, you don't have to set the materials at all. So mainly, you just need to actually make the assembly. Do the motion simulation. I believe it's a pin joint and a revolute joint and a chart. I think that's most of what you're supposed to do. So that's it for now. Thank you.